It's been just over 3 months since Sony first revealed the PlayStation 5 Pro in a to-the-point, detail-light presentation that didn't really hit the target. It's a far cry from the PlayStation 4 and indeed 4 Pro reveals, where impressive game demos were matched by extensive commentary from the lead system architect himself, Mark Cerny. The road to PS5. Again, it was Cerny's presentation that caught our attention. Yes, the technical detail was welcome, but perhaps more importantly, this was a statement from Sony on its vision for the future of gaming. But by the time you watch this, a deep dive into the technology behind PlayStation 5 Pro will be available. And Digital Foundry had the chance to see the presentation several weeks earlier at an in-person event at Sony HQ. And we also had the chance to interview Mark Cerny and Mike Fitzgerald, Insomniac's director of core technology. We'll be publishing that interview very, very soon. But today, it's all about the Pro presentation. And joining me to discuss it, first of all, our man at the event, Oliver Mackenzie. Hello.
Yes, I'm reporting back from San Francisco with a bit of a delay here. But it's going to be fun to chat about the PS5 Pro today and its various specifications.
Excellent stuff. So PlayStation 5 Pro focuses on ray tracing and machine learning-based reconstruction technology, something Alex Battaglia has been covering for us in depth for pretty much 6 years now. Hello.
Oh my gosh, yeah. It's been a while. But I was happy too. Just this morning, I set up my PS5 Pro, so I got rid of this extremely large machine, taking up so much desk space because the Pro is so much smaller, and I'm very happy about that. So also happy to talk about ray tracing, machine learning.
As always. Okay, let's begin then. So Oliver, the presentation kicks off with a look at what you might call the basics of PlayStation 5 Pro, the quote-unquote big three. But we've got a lot more detail now than we've had previously, and some clarification on I guess you could call them some fundamental errors that crept into the leak. So what's the deal here?
Yes, so Mark basically sketched out here as kind of a broad overview of the console that this is not a next-gen console, it's an enhanced machine. It's very much an enhanced machine. And in the interview we have coming up, he really made it clear that the focus was not really on the storage technology or the CPU, or even new display technology, even though the Pro can obviously support 8K displays and 4K 120Hz displays, but the focus is really on a better GPU for better graphics rendering. And to that end, you have the big three that we referred so much about, the larger GPU, the increased machine learning performance, and PSSR, obviously, and the much better RT performance as well. So those are the focus areas for the PS5 Pro that Mark sketched out here. And there has been a lot of discussion about the fundamental architecture of the PS5 Pro. As you mentioned there, Rich, is it RDNA 4? Is it RDNA 3+? What is it exactly? The reality is that it's actually RDNA 2 at its core, with some features that come from RDNA 3 and some that probably come from RDNA 4 in all likelihood, with what they're talking about with ray tracing performance there in particular. Basically, it means that at a typical clock speed of 2.17 gigahertz, that the PS5 Pro is capable of 16.7 teraflops of performance there, as opposed to the 33.5 teraflops that was quoted so often prior to this disclosure, which is much more directly comparable to the RDNA 2 teraflops that you would see in the PlayStation 5, as opposed to RDNA 3 teraflops, which are sort of inflated or flop-flated, as Mark put in the presentation. This wasn't in the presentation, but we do know from separate disclosures, I believe, to developers, that the GPU appears to have the full RDNA 2 feature set, including mesh shaders and a hardware VRS, I believe. And then in part because of PSSR, which can consume several hundred megabytes, and in part because of the presumption that developers will be targeting higher resolution targets for their titles, there is a need for additional memory here. And as we know from the PlayStation 5 Pro tech booklet, there is an extra 2 gigabytes of DDR5 on board. And Mark says that there's over a gigabyte of additional memory available to developers on the Pro. And then, of course, also on the memory side, we also know, as has been said many times before, and it was indeed part of that initial leak, that the memory is about 28% faster than the PlayStation 5's memory. It's still on a 256-bit bus, but they are using faster memory there. So you should be able to get a pretty comprehensive improvement in raster performance there. And then, of course, there's the ray tracing improvements and the machine learning improvements, which we'll talk about later. But that's kind of a broad overview of what the GPU is on the PlayStation 5 Pro.
Yeah, there is some confirmation of some of the leaked information. For example, the 30 work groups, 60 compute units, that's all come to pass, but that was pretty much confirmed already, really, wasn't it? GPU boost clock is 2.35 gigahertz max, which I think we talked about back in the day. Typical running speed, though, 2.17 gigahertz. I notice on the slides here that that is the same typical clock speed as the base PlayStation 5, and we'd kind of been under the impression that it was the full flat out 2.23, but it seems that 2.17 seems to be the typical operating running speed. So the Pro GPU can in theory run faster than the standard PlayStation 5, but it looks like in general operation it doesn't. So we still kind of think that there's a power limit in place that limits performance, right? And the fact that you've got a 2.35 gigahertz max, but a slightly lower general operating clock speed would seem to back that up. But I don't see anything in the presentation there that overtly confirms that, right, Oliver?
Yeah, that is true. They did not talk too much about power limits in the presentation. In subsequent discussions with Mark and in the interview, he said that the clock behavior of the PS5 Pro should be pretty much the same as that original unit, but he did stress that 2.35 gigahertz maximum clock rate in the GPU was unlikely to be hit by most titles in typical conditions. So you are still seeing a bit of a variable clock rate there, but again, presumably because of that die shrink, presumably because of the shrink down to a lower nanometer process node there, you should be getting a pretty comparable range of GPU clock to that original PlayStation 5 unit, it sounds like, from what Mark told me.
Cool. Now we've got to move on to ray tracing. Alex, this has all been a bit of a mystery up until now. We know from the leaked disclosures that there was, certain parts of the ray tracing pipeline were 2 times faster. Other parts of it could be like 3 or 4 times faster, I think. But now we've actually got firm details on what those enhancements actually are. And now, in theory, this should also transplant across pretty much like for like to the next AMD desktop GPUs, right? But can you talk us through what's actually going on here and how it is an improvement over RDNA 2?
Oh, yeah, sure. So the first grouping of enhancements are ones that are coming from later versions of RDNA. I think actually 3 up, because the comparison always with PlayStation 5 is it's got like this mid between RDNA 1 and RDNA 2 thing, but it takes the RDNA 2 aspects to do its ray tracing, which is repurposing the texture mapping units to do box and triangle intersection tests. And the first upgrade that PlayStation 5 Pro seems to have, and this one that also came out in leak, is just increasing the rate at which that is happening. So that is one smaller portion of the RT pipeline. Essentially, you shoot a ray into the scene, and then it has to traverse the BVH, find the proper box, and it hits it, and then test against triangles in it. So testing against the box and the triangle is one part. Then you have to shade and do all the other things after that. This testing against the boxes and triangles of inside this BVH of the geometry and everything, that is 2 to 3 times faster, depending upon essentially the scenario. And that's actually a pretty big deal for like more complex games. The next upgrade is a support for BV8H versus BV8H4. Now, this is actually more of I would say an AMD focused thing, because I believe this is their traversal shader essentially in hardware and how it's handled. And here, I believe the traversal stage has always been on RDNA to be done in a compute shader. And this is like the specific way that it is going to be done on RDNA 4 and above on AMD side. And this will offer a speed up as well too. And another thing that they added was stack management in hardware. Now, this is something I think that is maybe RDNA 3 and above, but I'm not exactly positive on that. I have to I've been trying to read up on it, but there aren't actually a lot of good presentations on it. But this is another aspect of the traversal stage in ray tracing. Essentially, before any of the triangles are or the boxes are tested against, you have to move around the scene and see essentially which node you're going to go into, which leaf. And this being accelerated in hardware to a certain degree is going to speed that up. This is one thing that Intel and NVIDIA have done in the past fully in hardware, and that has given them a great advantage. The last kind of thing that was pointed at in the presentations was divergent RT getting a bigger boost versus the standard stuff. So most of the console games we've seen so far that have used ray tracing try and keep it very non-divergent. And they do that in a number of ways, essentially making materials that could potentially affect ray tracing. Like you only use the materials that are more shiny, more mirror-like for reflections or for GI, because anything else that is more diffuse is going to cause the ray to go off in a direction that is less, it's more divergent from the original ray vector, essentially. It can go off in a different direction. Another way they do it is by limiting essentially the material response that is going to be tested against later on. And so that's why you don't see something like path tracing on a console, because that extremely explodes the performance. On NVIDIA and Intel side, Intel has a hardware sorting unit actually to take care of divergence, ray divergence by binning the rays, if I'm not mistaken. And on NVIDIA side, alongside with the traversal unit, just helping that a little bit, just like it does on Intel, they also introduced a hardware invocation that can be brought about by using their shader execution reordering, which is entirely, it's like an addendum to the DirectX API, which is not official actually. And it's not exactly completely described how it is here, but how it is achieved and why it's so much better. But I think the traversal upgrades, the BVH8, is making it so that divergent workloads are much better. So that would mean games that have potentially RT reflections on PS5 Pro, unlike, for example, like in Spider-Man, where it's usually just mostly mirror or near mirror reflections, they could have it encompassing the whole range of reflectivity. So you could even have very rough reflections. A lot of stuff that is building toward the future that is ray tracing. And that was another thing that I noticed while looking through your notes, Oliver, was that Mark Cerny postulated, I think, something that I really agree with, that there's like a limited road to how far we can take rasterization. And one of the avenues to go beyond the limitations there that has larger scaling potential, because it's such a open field for research and techniques, is ray tracing. And this hardware and stuff that we're seeing from RDNA 4 is pushing much more in that direction. And it's awesome to see, actually.
So anything about this from upcoming Radeon GPUs that you could possibly extrapolate? I mean, obviously they will do better ray tracing, but it does seem to be a significant upgrade, but still quite divergent from what NVIDIA are doing in terms of core architecture.
Yeah, I mean, there isn't the equivalent of the RT core still. And I think that just... the RT core is good in the aspect of that it allows for more concurrent workloads as a result, whereas this potentially will not have that. So it still won't necessarily be as extremely competitive with NVIDIA's like path tracing stuff, but it's still better than what you had in RDNA 2 by far. And I think it's hard to point at it, because on the RDNA 4 side on PC, one thing that AMD has talked about in their presentations is how they're leveraging greater amounts of cache that they're throwing on the chips to make their performance much better on the PC side than it would otherwise be without it, because they can fit in more of the things in the BVH actually on chip memory. And that is an advantage that they get on that side of things. And that not being here, it's curious to see what then RDNA 4 will perform like on PC with much faster memory access, which is a huge aspect of why ray tracing is so incredibly slow. So yeah, it points basically towards, at least on the software and hardware side of things, that AMD is going to be accelerating in this direction much more than they have in the past. And they're not ignoring it anymore, which is great.
Okay, cool. So you've got the big three, right? We've got the base technology per the slide, which is RDNA 2. They're calling it 2.x. So it's kind of like a custom, a revised version of RDNA 2. Ray tracing comes from future RDNA. Machine learning, custom RDNA. Now, this is quite interesting, right? Because one might expect that if there was a future RDNA machine learning based feature that Sony felt comfortable with using, they would be using it. Instead, Oliver, they've effectively rolled their own, right?
That's correct. So here, the earlier presentation on the ray tracing capabilities, I feel, was a little bit shorter, if just because it was borrowed AMD technology, but this is indeed quite custom Sony technology, it seems like, from Mark's presentation. So the main focus on PS5 Pro is machine learning upscaling here, basically a technology similar to DLSS2 or XeSS. And here, I suppose the task was adapting RDNA 2 to be more suitable for machine learning. And the scope of the presentation, really what Mark said as well to me, was they really wanted to focus on speed and having their PSSR upscale process take as little time as possible. So they had a choice between an NPU solution and a GPU solution here, and they ended up going with a GPU solution. But the problem is when they actually started approaching this problem here and adding extensions for machine learning and actually trying to get machine learning performance up to an acceptable level, is that you start running into limits when you have to start hitting system memory, because you really need so much bandwidth for machine learning operations. You get like absurd levels of bandwidth boundedness to the point where like fitting them onto ONDAG caches produces like a really absurd speed up. So anytime you're hitting system memory, you're getting a huge decrease. And indeed in the slides, what they're talking about was like their initial work on this was showing like a 3% utilization of the 300 tops on the PlayStation 5 Pro here. So the goal was really to get the data on die working through all the layers of PSSR, which is a convolutional neural network, and then out and read back or written back into system memory at the end of that process as quickly as possible. The problem they sketched out was that would require a ton of memory, which Mark said would be about 120 megabytes for a 4K image. The answer is basically to take a smaller portion of that image through the chip at one time, but then you end up with some problems where the edges lack information about surrounding tiles. They need to be thrown out. There's some edge data that needs to be discarded there. In the end, the solution that they found that worked for them was to combine their vector registers in the WGPs, giving them a total, I think, of 15 megabytes of memory and about 200 terabytes per second of memory bandwidth. And so that was the solution they ended up going with. So it's kind of like if you look at the solution that AMD adopted for ray tracing, it's sort of similar to that, where it's not using a dedicated RT core hardware in there. They're still using the shaders. They're still using that generalized functionality. It probably is fairly die efficient, pretty lightweight in terms of GPU die area, I have to imagine. And it's also probably fairly adaptable within AMD's existing architecture. Like, I don't think they're making huge changes to RDNA here to facilitate this. And it does seem like they're able to achieve basically getting PSSR running quickly enough. It's not quite fully fused, as they call it. They are still hitting system memory at various points using PSSR beyond just that initial read and end write process. But it does sound like they're able to get it to a level of performance that they're comfortable with and happy with. And obviously it does work for PSSR in the shipping unit. So it does sound like they achieved their goals here.
Mm-hmm. Mm-hmm. Alex, you must have been poring over these details with much interest.
These are great. I think this is really cool. I really wish, I mean, it's not so consumer friendly, but I just looking over Oliver's notes and listening to the interview, it's a lot of stuff that I wish the original, like we had a road to PS5 Pro, that would have been really cool. Because it's talking about essentially the trials and tribulations of trying to make something performant on a GPU and within a hardware budget. And that's something that they tried very well at. And there's the admission here that it's actually not as far as they would like to go. The maturity of the network is a whole other question, because as we've seen with some other launch games, like lower resolutions, and there's some bugs at the moment. And I think even, Mark talked to you about bugs that they incurred.
Lots of bugs.
That they occurred in the testing process. Because we've also seen bugs in the past with things like DLSS and XeSS. For example, DLSS had a really long time recurring bug of sitting still in a game, and after like 9 or 10 seconds, some objects would just start blurring crazily. And it lasted in the model for like a year, maybe longer. And that was there. So that these things happen. But regardless of those type of issues, another thing that they're going to try and do over time here is to get the network fully fused. Now, this is something that I remember when we were talking with Tom Peterson. He emphasized that the first iteration of XeSS that they were going to put out was going to be a fully fused network. And that was evident definitely in the performance of XeSS on hardware that had their XMX units, where it was basically the same cost of DLSS. Now, on a 300 top style, like size GPU, DLSS is below 1 millisecond these days. I think it's like 0.7 or so on a GPU with that many tensor ops, I believe. And PSSR currently is around a little bit more than 2, potentially, based upon the internal document leak, as well as our super rough measurement in God of War Ragnarok, which is not the complete measurement, by the way. And that implies that over time, if they can work on the network more and get it more in budget, so to speak, games that run PSSR could potentially run faster, with later versions of the model library being called. Which would be great, because right now PSSR, probably you'd want to limit it to games that are targeting 60 or 30, but in the future you'd really want it also for those games that target 120 FPS, right? Because right now it's one fourth of their millisecond budget, which is probably too much to spend on upscaling. I think that's really cool. I would love to see greater iterations of PSSR over time, just like we saw with on the NVIDIA side of things, where also DLSS's runtime went down from the initial versions, definitely in comparison to DLSS 1, for example, as well too. Also, I think for future RDNA, I imagine this is the route that is going to be the one that also AMD uses, that Sony did too here, where there's going to be modifications to the main CUs to make it performant enough to run CNNs locally on the GPU. And I think we have hints at that as well, Oliver.
Yes, well, we can talk about that a little bit later, but there's an AMD and Sony technology collaboration to try to further machine learning performance across their GPU architectures. But one detail I thought was fun here, and I know we were obsessing over this for a little bit, or at least Alex was thinking about this quite thoroughly here, was that spectral name, that PlayStation Spectral Super Resolution.
Yeah.
And it turns out from Mark that spectral means nothing, nothing at all. He said that's basically their branding for machine learning technologies and libraries that will go into their products. So like Tempest Audio Engine, PlayStation Spectral something, right? Presumably that would be the way they go forward with this. Is Spectral is basically their big machine learning brand here. Doesn't mean anything in the context of PSSR.
What a shame.
Yeah, it's a bit of a shame.
Mean, there's also no Shakespearean callback there, is there? Spectral? No. It wasn't Tempest and all these other things.
That's interesting.
Weren't they all references to Shakespeare plays?
Well, maybe someone at Sony marketing has this in their head, but Alex apparently. But, yeah.
So the weird thing is, of course, that PlayStation is PS and Super Resolution is SR. So you didn't need the Spectral to begin with. You could still have had PSSR.
It's whatever. But the funny thing is, talking about the tiling scheme that was described earlier, where tiles would then have to maybe share information across their boundaries, which messed up the whole ability to stay on system cache. Oliver, that is, interestingly enough, somewhat referenced in the weird patent for... do you remember the weird machine learned upscaling
the patches upscaling patent?
Yeah, the upscaling patches, where different patches would be done with, they broke up the screen into tiles, very small tiles, where certain ones would be done with machine learning capabilities on the GPU, while other tiles that were deemed less worthy, so to speak, of a more complex upscaling process would use just standard spatial upscalers. But the idea of breaking up the screen into tiles was actually, weirdly enough, already in that patent from all the way a while back that had Mark Cerny's name on it. So they were thinking about it for a while.
Interesting. I think, looking at what everything that's been disclosed here, Sony is basically looking to produce an enhanced console for today, but with an eye to the technologies of tomorrow. And, it's kind of like highlighted by the fact that, rasterization can only go so far. That's borne out in the PlayStation 5 professional design, right? The GPU hasn't been doubled this time in the way that it was with the PS4 Pro, certainly in terms of compute performance. Instead, it's kind of like a kind of mixture of new techniques, right? Exciting ones, machine learning based features. At the moment, it's just upscaling, right? But this kind of hardware can be used for all manner of different features in theory. Ray tracing, obviously, the future is ray tracing. It's kind of like undeniable at this point. So, it seems to me that they've had to kind of like produce these new technologies, but somehow work them into a design that is backwards compatible with the existing PlayStation 5. And I think it's really fascinating to see what they've come up with here, because, when NVIDIA rolls out a new graphics card, or AMD even, it's effectively a clean slate. It's a complete new architecture. They could do whatever they want. If you look at the transition from Pascal to Turing, the introduction of those RT cores and the tensor cores, that is an option, I guess, just wasn't available to Sony here if they wanted to produce a machine that was 100% compatible with the existing PlayStation 5. But I think the direction of travel in terms of where future technology is heading, in terms of consoles, it's all starting here. And of course, Switch 2, of course, which has a very, very similar feature set. So, yeah, absolutely fascinating to see all of this detail laid out for us. But where do we want to go next, Oliver?
Yes, well, Mark closed off the discussion with a bit of a look towards the future, which I thought was quite interesting. So yeah, he said that in terms of raster performance, as he put it, he's not too terribly interested in just making GPUs larger and larger. He basically said that increasing raster performance by adding CUs, adding memory bandwidth, making larger memory interfaces possibly, it's something that worked well in the past, but there's not a lot of growth left there. I think you see that with more modern chips now, with GPU prices going through the roof, and obviously, you need to fit so many GPUs on a certain wafer, and that being very, very expensive now. But he said that for ray tracing, there are quantum leaps ahead, but presumably there I would kind of think that is AMD-led. That is an AMD-led portion of their technology collaboration here. And he says that machine learning, though, has the greatest potential for growth, and not just in upscaling an image to higher resolutions, but also in other kinds of machine learning enhancements to game graphics, possibly gameplay, other areas. He seemed very, very interested in this when I spoke to him. He seemed very, very interested in this when he was talking about it during the presentation. And to that end, AMD and Sony are entering into a bit of a technology partnership called Amethyst, which, if you looked it up, I looked it up after the presentation, it's a purple variety of quartz. And now if you combine AMD red, Sony blue, you get purple, which is, I think, the idea behind the branding.
Sapphire, two different types of sapphire.
Sapphire, ruby, amethyst, something like that. And I think the interest on Sony's side, it sounds like, is really in making architectures that work well for lightweight CNNs for real-time game graphics, and that can be used for fully fused networks for graphics rendering. That's really their primary interest. But they will be working on high-quality CNNs, and both parties apparently will be able to access those network architectures for their products. So it sounds kind of like, AMD is leading the way on the main GPU designs on RT, but Sony and AMD have this collaboration for machine learning that is hopefully going to take those GPUs and basically get them to a space where they are being able to push out more advanced technologies, because, as Mark puts it here, you aren't really going to get the progress that you want in graphics technology without embracing ray tracing, without embracing machine learning. You just aren't going to get there.
Mm-hmm. So in a sense, it is kind of like a PS5 Pro is, in a sense, a kind of proving ground for these new technologies. It's getting hardware out there to build upon, right, Alex?
Yeah, and I think this is really necessary. As we saw with DLSS, it took hundreds of games and years of essentially training iteration over time to get it to the point where it was right now. And if it just stays within the Sony ecosystem, it arguably won't get as high quality as it could. AMD iterating on it in their own sense, leveraging their resources as well as maybe training data will make the model that they end up come up with for PSSR when it's fully done. Like right now, we're just the very beginning of it. Will make it better and more resilient. And I think that requires the hardware and software of multiple companies, because AMD doesn't have nearly as much R&D as NVIDIA. And I think this is actually a great way to kind of bridge that gap that they don't have. And it's great. It also makes me wonder a little bit if the talked about, where we still don't know about a lot about it, but FSR4, if it is going to be a branch of PSSR essentially on PC, which would be interesting. If that were the case, it makes me wonder where Microsoft fits into that future, because they also run AMD hardware on their consoles. And I also like that here, it's not just about upscaling, it's just about computer graphics in general, because I think denoising is a great place in the future. I also think utilizing the limited bandwidth that we have and also limited memory space that you have on consoles, and using things like neural networks to increase the quality of textures, texture streaming, or even geometric quality at some point in the future, I think, based upon some sort of previous data. I don't think just making things up like a generative network is necessarily the current future, but especially for things in real time. But I think those are great directions, and I think that's exactly where PS6 is going to land. And something like Amethyst is going to make sure that it is actually doable within a reasonable amount of time. So yeah.
Cool. Did you get the sense that Amethyst is both a hardware and a software thing? Is it training models that they can use in common? To what extent does this collaboration go? What was the sense there, Oliver?
Well, Mark said there are basically two parts to it, and the first part is basically a collaboration around hardware architectures. So having GPUs that are very capable for machine learning performance, and in particular really good at processing lightweight models that might be used for real-time game graphics. The other kind of goal there is basically to do some cross-firm development of high-quality CNNs for game graphics. And there will be some collaboration on the level of like the network architectures of those CNNs. So reading between the lines here, I would assume that basically that would probably feed into something like FSR4 or whatever AMD might be doing with machine learning next. And obviously that would also feed into presumably PSSR as well. You know, to this end, I kind of have to think that at this point, the cat's kind of out of the bag on like a PlayStation 6 in terms of it being an AMD architecture, because certainly you don't announce a technology partnership like this one without there being an intention to continue that technology partnership for the next generation of your flagship product, I would presume. They've already done 2 generations with AMD already. Backwards compatibility would be a major focus. x86 would be a major focus, possibly, probably there. And then, of course, with Amethyst, you know, I think this is a technology collaboration. Mark told me in the interview that it'd be a technology collaboration that he didn't expect would yield dividends necessarily in the next year or two, but would be something that we would see the results of in the next few years, with an emphasis on the longer term horizon of that possibility. So I would presume that this would be something that would play heavily into Sony's plans for the PlayStation 6.
Mm-hmm. Yeah, I think this is absolutely fascinating, because if you look at, essentially the transition between PlayStation 4 to PlayStation 5, there was a lot of great stuff there, right? The CPU problem was greatly reduced. Zen 2 was a pretty good fit in terms of area, in terms of performance. Graphics, obviously, you had a pretty big leap on the GPU side. Ray tracing was brought into the fore, but where do you go next? And it's, the roadmap here is pretty straightforward, right? The transistor budgets aren't just there to double GPU size anymore. And you've got to be more innovative with how those transistors are being used. And it looks like, Amethyst is essentially a statement of intent, which is like, okay, machine learning is the future. But what does that future actually look like? Let's work together to kind of figure out a solution here. I think it was really, really fascinating stuff. I mean, a lot of stuff has been solved by PlayStation 5. The storage problem has been solved as well. effectively. You've got that quantum leap in bandwidth to the point where I don't think it's still being used to its fullest extent even now. So, there's a lot of great work that's been done in the existing generation. And what we're seeing here is almost kind of like experimental, but with obvious initial rewards. PSSR, when deployed in a good implementation is literally game changing for something like Final Fantasy VII Rebirth. So, there's a lot of initial big wins here. But I think there's bigger stakes at play here. I don't know what you think, Alex. This is literally the future of gaming technology. And this is kind of like the frontier work, so to speak.
Yeah, I think the stakes for AMD are very high because they're ever shrinking desktop share, and they want to still be competitive with the desktop market, even if they can't compete completely within it, but they can compete completely, obviously, on the handheld and console side of things where they dominate, and they are the market there. But to prevent consumers from going from one market to the next and only exclusively being in that one, for example, PC market with NVIDIA primarily, you still want to push technology as far as you possibly can within the budgets of a console. And this is the initiative to start doing it. And I am very, very curious, though, about PS6, about what it's going to look like in hardware now, because Mark in this presentation, once again, was talking about memory bandwidth and staying on chip as much as possible. Yet we talked about this most recently in the Direct too, but the whole cache situation of making AMD on their side is pushing so much more cache on their GPUs and CPUs to essentially bring performance up to the level that they think is competitive, but they're not doing that on the console side yet. And I'm curious to see what PS6 is going to look like, because they emphasize it again for machine learning. It's a huge part of ray tracing. And in general, it's the way CPU performance has gone up so much. So what will PS6 look like hardware-wise as a result of Amethyst?
Yeah, there's something else that interests me as well, the whole concept of disregarding the MPU, which is essentially a separate block for machine learning functions. And AMD is all in on that for their mobile chipset, seemingly. But not here, not in the PlayStation 6. It's just not a good fit. So that was interesting as well. Any final thoughts, Oliver, before we wrap this up?
No, I'm excited to see where things go, but I'm excited to see where things go in particular on the software side going forward. Because obviously we've seen some really great PS5 Pro patches. We've seen some that are a little bit more in need of possibly further work there. I'd be very curious to see exactly what we see in the future. If we do end up seeing, for instance, some titles that might use more extensive ray tracing on PS5 as a result of those ray tracing enhancements, if we might see titles that really do scale in a way that's really compelling, that possibly might even be using technologies like path tracing, might be using much more heavily ray traced lighting. We've already seen with titles like F124 that you can really push out ray tracing on the PlayStation 5 Pro relative to PS5 by using PSSR, by using that enhanced ray tracing performance in that GPU. And of course, being able to leverage that much higher level of compute and higher level of generalized memory bandwidth as well. I'd also be curious to see, because this is a console, I'd be very curious to see what Sony does with older software as well. Like we've already seen the enhanced image quality feature on PS5 Pro. Could we see something like FrameGen? If they do leverage some FrameGen technology in the future, could they leverage something like that for PS4 software? Because the great thing about new games is they always take advantage of the hardware that you have. The great thing about PC is they can always take advantage of the hardware that you have. But unfortunately, on consoles, given the constraints of how games are written, unless you have some, interesting new capabilities that can only be leveraged in certain older titles with specific hand-tuned work like we see on the Xbox side of things, those games are sort of frozen in ice. So could you introduce some machine learning technologies when you have a much larger GPU, when you have much greater machine learning capability in that GPU, sort of like we see with enhanced image quality, but just push it out further? I think that'd be very interesting to see, especially given that you'll have a console with 2 generations of hardware backwards compatibility. When we get down to the PS6, during that period, you're going to have a lot of software potentially to work with, and a lot of software that people might be interested in revisiting on that newer console. They'd be hoping for some enhancement there potentially. So I think this is a really compelling presentation. I think it shows where Sony is at with regards to their collaboration with AMD, where they'd like things to go in the future, their areas of interest across both firms. But I think ultimately it's going to be the tale of the games here. And I think we're going to need to see some really high quality pieces of software on PS5 Pro. And we're going to need to see in particular how technologies like PSSR develop and how Sony's machine learning push develops, presumably with technologies like frame generation, with RT denoising, with things like this in the future. Presumably those are going to be a part of it as well.
Mm-hmm. Excellent stuff. Yeah. Well, I really enjoyed this presentation. It was great to get the inside track. So thanks for that, Oliver. But that's the end of this video. So please do like, subscribe, share on the off chance you enjoyed it. Ring bells for notifications that may or may not happen. DF Supporter Program. Join us. Join our community there. Help support the team. It's really, really important stuff. We'll be back soon, I guess, Oliver, with your interview with Mike and Mark.
Yes.
Okay, so do look out for that. But that's all from us on this one. Thanks for watching and supporting Digital Foundry.